All right, so let me do a quick recap of where we were 3.1 last week. When we started 3.1, we started talking about what a statement was, this idea of something being automatically true or automatically false. There's no gray area. We talked about compound statements being formed by using some connective between them, and the three most common kinds of connectives are the words and, or if then. Okay, and we had taken a look at negations as well, and when we were talking about negations, we were talking about changing the way that a statement is worded to be the logical opposite. And we said that that's easy some of the time, and some of the time it actually requires us to think a little bit more specifically, and those times are when we have words that are called quantifiers involved. Words like all or every or none or some, they make us think a little bit more critically about how that would work. And we'd left off with this diagram. These are some different symbols that are related to these different kinds of concepts. So and is an upside down V, or is a V, and then the tilde represents the word not or the negation of something. Okay? So what we're going to do next is we're actually going to take symbols and turn them into English language. And then we're going to go and take English language and turn them back into symbols. Okay? So if you take a look, this problem, like the ones that you're going to see in your homework and whatnot, actually give you some details. They tell you what P is. P is going to be the statement, she is a teenager. And then they give you Q, and Q is going to be the statement, he is a lawyer. So when you see this statement down here below, you have a tilde and then a P. So what would tilde P mean if P is, she is a teenager? And what would the negation of the statement be? Do you know, Ethan? She is not a teenager, exactly. So we'd say she is not a teenager. Now after the tilde P, we have this upside down V symbol. What's that mean? That's and. So we're going to use the word and. And then we have the tilde Q. And what is tilde Q going to be? Right, he is not a lawyer. Okay, so we can take symbols, we can turn them into language. And on the next slide, we're going to go back the other direction. So the symbols are described almost the same way, not exactly, but close. So it says that P is the statement specifically that Leah is a teenager, and then that Q is the statement specifically that Joe is a lawyer. So we're taking this language, Leah is not a teenager, and we're going to use symbols to represent it. So what would that look like in symbols? Tilde P. Because the language they used was P is that Leah is, yeah, it just depends on the letters that were used. So P is she's a teenager. Yeah. Then what am I going to use? Okay, I need a symbol for the word or. It's a V, that's right. So it looks like this. Okay. And then I need a symbol, so I've got right here, Leah is a teenager, that's tilde P. I've got the or, and then I need Joe is a lawyer, and that's Q. So this sort of has the same feel of when you were really young, and somebody gave you some kind of a puzzle where they said the number 5 is the letter A, like a code book, right? And the number 7 is the letter T. And you use those numbers and those letters to just kind of fill in some sort of a Bible verse or something like that. Did anybody ever do something like that when you were a kid? This has the same kind of feel to it at the moment, and I get that. So it's not real, intuitive of like, why am I doing this? This doesn't seem to really be doing much for me. I promise we're going to build on this, okay? But this is where we have to start so that we can actually get to where we need to head next, all right? All right, one more topic that we're going to take a look at, which is really nice having come off of your last test, talking about types of numbers, because we've talked about all these types of numbers before. We need to decide whether the statement involving a quantifier is true or false. Okay, so think back to that diagram I drew with the real numbers and the rational numbers and irrational and the embedded squares and different things. We have that kind of a picture. And the first first statement rather says, all irrational numbers are real numbers. And we have to decide if that's true or false. if you say it's false, you have to give me an example of something that is irrational and not real. So what are irrational numbers? Pi, you bet. What else? Radical 2. Square root of 2 would work. What else? What else? E, that's right. E is an irrational number. All those are types of irrational numbers. Are all of those also real numbers? Yes, they are. The picture you should have in your mind looked like this. This was the real numbers. All of them. Everything inside here was real numbers. And this piece, when I drew the picture, was the irrationals. All the irrationals were inside of the real square, rectangle, whatever. So this is a true statement. Irrational numbers are real numbers. So are rational numbers, right? Yes, they are. Okay, similar idea on number 10. Each, the word each is the same thing as the word every or all. Okay, so it's talking about all of the whole numbers or every whole number. Every whole number is a positive number. It is false. Can you give me the example or an example of why?
0.
0, exactly. 0 is a whole number. It's not positive. It's not negative, but it isn't positive either. So this would be the example of why this is false. Now, your book's not going to ask you to give an example, but I want to challenge you that if you write down false, you better be able to come up with an example. Because if you can't come up with an example, you might need to change your vote to true. Does that make sense? Because if it's false, you better have a reason for believing and thinking it's false. It wouldn't be a bad idea to jot that down so that you'll remember when you look back at it later why you said it was false. All right, this is it for 3.1.